The third individual gas law we're going to talk about is Avogadro's law. And based off of the title, you can guess that this law is going to involve something regarding moles, since it has Avogadro in it, and that's a great guess, and you would be correct. So Avogadro's law simply says that the volume of a gas is directly proportional to the amount of gas, specifically in moles, if you are at constant temperature and pressure. Mathematically, that statement is V1 divided by N1 is equal to V2 divided by N2, where 1 means initial and 2 means final conditions. So generally, problems that involve Avogadro's law deal with a sample of gas that has just one identity, meaning you're adding more moles of the same kind of gas. The example that's given in your MindTap online homework is similar to the one that I have down here, where you are given a chemical reaction and amounts and volume of that chemical reaction, and you're asked to determine the volume of the sample after the reaction has taken place. So being able to use Avogadro's law with an example that we're going to talk through here shortly is instructive, but we need to do a little bit of math to determine what mole values we use. What do I mean by that? So in this problem, it says that we have a sample of gas that contains a certain amount of C2H4 and Br2, and we know those mole amounts of the reactants, and we know that the total volume that those gas reactants contain is 17.7 liters. We're given a balanced chemical equation, and we want to know what the volume of the sample is after the reaction has taken place. After all of my C2H4 gas has reacted with my Br2 gas. So we can use Avogadro's law to solve that problem. We just need to make sure that the initial and final conditions we use are of the actual reaction. So that means that for my initial conditions before the reaction, I'm going to use that total volume of 17.7 liters. But my N1, my initial moles of gas, is what I have in that 17.7 liters of reaction, which is the C2H4 and the Br2. So my total number of moles before the reaction is 0.180 times 2, or 0.180 plus 0.180. So that is the value of N1 that I use in Avogadro's law. For after the reaction, obviously I'm solving for V2, but for N2, I need to make sure I use the moles of my products. What are my products in this reaction? This big molecule here. I wasn't told how many moles I have of that molecule, but I do know from the balanced chemical reaction that's given in the problem, for every 1 mole of each reactant, I get 1 mole of product. So if I have 0.180 moles of each reactant, I'm going to have 0.180 moles of my product. So my N2 is 0.180 moles. And so using those values and doing a little bit of algebra on the Avogadro's law statement, I plug in those specific values. I see my mole units cancel. I'm left with liters. Doing the multiplication and division, I get a sample volume of 8.85 liters. Smaller than the volume of what I originally started with, but that's expected because if you think about it, I'm taking more moles of gas and combining them into a smaller mole value. So my volume of gas should be smaller. So this example is very similar to one that is in your MindTap, and so I would use this example and this video to help you solve those kinds of problems with regards to Avogadro's law.